Hello and welcome. In this video we're going to learn about the 12 StatusWatch data types. Now because this is a slightly abstract set of concepts, I won't be mousing around the application for this one. Instead I'll be using some simple animation. So let's get started. Each of the 12 StatusWatch data types is made up of one of 3 prefixes and one of 4 suffixes. The prefixes are continuous, instantaneous, and immediate, while the suffixes are string, integer, number, and boolean. We're going to start by tackling those suffixes. A string is, in the simplest terms, any series of letters, numbers, and symbols that you want. The word factory is a string. So is the address of the StatusWatch offices. So is your name, my name, your favorite foods, your IP address, etc. Nearly any mixed collection of characters can be a string. As such, strings are very useful. They can contain pretty much whatever you want. That said, strings have some limitations. It's difficult to perform math operations on strings. What do you get when you add 35 degrees Celsius and Mary had a little lamb? What about if you multiply? Or divide? I don't know either. That's a relatively obscure example, but it helps illustrate some of the limitations of strings. Next, we're going to cover integers. An integer can be a 0 or any positive or negative whole number. Within StatusWatch, an integer might be used to indicate the number of parts that have been completed by a machine, or the number of seconds a machine should take to produce a part. Integers cannot have, however, decimal values. Decimals are reserved for the next data type, which is numbers. Numbers, like integers, can be positive, negative, or 0, but they may contain decimal values. This allows for more precision than what you'll find in an integer. For example, an integer representing the value of pi would not be very precise. Once you make it into a number, however, you can add far more detail. In StatusWatch, numbers are useful anywhere that you want more precision than what an integer will allow you. On to the last of the suffixes, and that is booleans. Boolean is just a fancy word for a value that can only be true or false. If my car is in the shop being fixed, it could be said that car in for repairs equals true. Once the maintenance is completed, car in for repairs equals false. Because the car is old and falling apart, a boolean of I drive a clunker equals true. Someday when I buy a fancy sports car, maybe a Viper, I drive a clunker will be false. Almost anything can be expressed as a boolean, but as with strings, there are limitations. Math is equally difficult on booleans, and overusing booleans can make your data unnecessarily complex. For example, the age of my car could be expressed as a boolean by saying car age is 25 equals true. However, 1 year from now, this boolean will no longer be useful in displaying how old the car is, only how old the car isn't. In order to display the age accurately using booleans, I would need a whole slew of them. It'd be a big mess. You can see that in this case, a boolean just isn't the right way to do things. An integer would work much better. Car age equals 25. Let's review. If I were interested in storing my car's odometer reading using StatusWatch, I have 4 options. If I were to use a string, it might read 124,000.5 miles. If the same value were expressed as an integer, it could be 124,000. Remember that integers can only be whole numbers, so our 0.5 would go missing. If I really needed that precision back, we could use a number and display the value as 124,000.5. Finally, we could use a boolean, perhaps simply saying that mileage over 100,000 equals true. Now, which is best in this scenario? Well, the boolean certainly isn't, because the statement mileage over 100,000 equals true could be used to describe a car with 100,001 miles or a car with 1,000,000 miles, so boolean, no. The string, while accurate, might be a little unwieldy. Because math is hard to do on strings, we'll have to rewrite the entire phrase every time the mileage changes, so let's say no to the string as well. The integer allows for easy math, but it's not quite accurate due to the absence of that decimal point. That leaves a number. It allows for math operations and lets us be as precise as we'd like to be. In this scenario, the number is the best choice. That covers the 4 suffixes. Now let's talk about the 3 prefixes, and we'll start with continuous. Continuous data types have 2 important characteristics. They have a time component, and they always have a value. Let's get right to the examples. On my car, the on-off state of the engine could be expressed as a continuous Boolean. It has a time component. At one point it's on, at another point it's not on, and it always have a value. So it's always either on or not. It could be displayed like this. Here we see that up until about 10 o'clock the engine was off. Engine on equals false. At 10 I turned the engine on, and engine on became true. I drove for 20 minutes, perhaps to the store, turned off the engine, did some light shopping, and 20 minutes later returned to the car and fired it up for the drive home. It's important to note that I could look up the value at any point along this timeline and see that the engine was either on or off. For example, at 10:05 I was on my way to the store and the engine was on. Let's look at some more. While I'm driving my car around, the engine temperature fluctuates. Within the scope of this example, the engine started out running at 99.4 degrees, then at 6:40 the temperature was up to over 101 degrees. By 6:50 it had nearly reached 103 degrees, and at 7 o'clock it was back down to 100.5 degrees. While my engine's temperature is going up and down, other things about the car are changing too. Perhaps I'm a fickle radio listener. I start out listening to WPBG, then decide to switch over to WGLT at 6:41. At 6:53 I switch to WBNQ, and by 7:02 I've jumped to WRPW. In this example, the call sign of my current radio station of choice is being displayed as a continuous string. On to our next prefix, instantaneous. Like continuous data types, instantaneous ones have a time component, but they do not always have a value. Instantaneous data types are often used to record occurrences of events. So, for example, my car often needs gas, and when it does, I go to the gas station and I charge the purchase to my credit card. Those charges could be recorded as an instantaneous number. In this example, on December 7th, I charged $38.07 to my card. A week later, I charged $42.14, and so on. Remember that instantaneous data types do not always have a value. I was not constantly charging $42.14 to my card every moment from the 14th to the 27th. If I were to look up this value on December 20th, meaning how much was the charge to my credit card for gas on the 20th, I would see that there was no value at that time. I didn't go to the gas station on that day, therefore there's no valid value for how much was charged to my card. Let's look at another. Suppose each of those times I went to buy gas, I did so at a different gas station. The names of the gas stations I visited could be displayed as an instantaneous string. On the 7th I went to the BP, on the 14th to Sunoco, on the 27th to Shell, etc. Just like in the previous example, were I to look up the value of this data at a timestamp between 2 of my fuel stops, I would not find a value. I was not constantly filling up my car with gas from December 27th until January 8th, therefore trying to find a value at January 3rd would be invalid. Next, let's discuss the final of the 3 prefixes, and that's immediates. Immediate data types have no time component at all, only a value. These types are used for data that either never changes, or if it does change, the historical values are of no interest. The benefit of immediate data types is that they take up very little space in the database. The downside is, of course, that in doing so they provide far less useful information. For example, the year in which my car was manufactured could be an immediate integer. It was built in 1985, and that's never going to change. Also, the car's make and model might be displayed as an immediate string. It's a Yugo 45. It just is. It wasn't a Porsche last week, and it won't be a Lamborghini next week. It just is a Yugo 45. Let's review. We have 3 prefixes and 4 suffixes. Any prefix can be tied to any suffix. An example of a continuous number might be my trip odometer. It has a time component, it always has a value, and that value is best expressed using decimal precision. An instantaneous string might be a passenger entering the car. At a specific moment, a person got in my car and they had a name. Like at 5:15, someone got in and his name was Mike, etc. An immediate integer might be my car's engine size measured in cubic inches. The value is set, it won't change, therefore no time component is needed. A continuous Boolean could be the status of my license plates. They're always either expired or not expired. The vehicle identification number of the car could be an immediate string. It's never going to change and may contain both letters and numbers. Finally, my clocked speed as seen by a police officer might be an instantaneous number. At a specific time, Officer Jones used his radar gun to determine that my speed was twice the posted speed limit. How I managed to reach this speed in a 1985 Yugo 45, I don't know. But that covers it. That concludes the discussion of StatusWatch data types. Now, as you go about the rest of your day, try to think of other examples of continuous, instantaneous, and immediate data in the world around you. It'll help drive home the concepts in this video. We'll see you in the next one. Thank you.